dear students. Now today we are going to see what is all about PUT. The PUT is nothing but Programmable Unijunction Transistor. The course outcome for this is you will be able to select power electronic devices for specific applications and maintain the performance of thyristors. The learning outcome, the student will be able to identify the given thyristor family device and triggering device. You will also be able to explain with sketches the working of PUT. So let's get started. What are the prerequisites required for this? Before studying the PUT, that is Programmable Unijunction Transistor, you must be able to understand, and we have already studied what is meant by UJT, operation of UJT, VI characteristics of UJT, applications of UJT. So, Programmable Unijunction Transistor or PUT is a close relative of the thyristor family. It has 4-layered construction just like the thyristors and have 3 terminals named anode, cathode and gate, again like a thyristor. Yet some call it as a programmable unijunction transistor just because its characteristics and parameters are much similar to that of UJT. It is also called as programmable because the parameters like intrinsic standoff ratio, peak voltage, etc. can be programmed with the help of the 2 external resistors. In a UJT, the parameters like peak voltage, intrinsic standoff ratio are fixed and we cannot change it. Now, what is intrinsic standoff ratio? We have seen in UJT there are 2 resistances of the base terminals RB1 and RB2. So, the intrinsic standoff ratio is the ratio of RB1 upon RB1 plus RB2. Its value is generally in the range of 0.4 to 0.8. The main application of PUT are relaxation oscillators, thyristor firing, pulse circuits and timing circuits. The PUT series which is most commonly used is 2N6027, which is the most common type number PUT. 3-terminal thyristors device which is triggered when the voltage at the anode will exceed the voltage at the gate terminal. The PUT is similar to unijunction transistor UJT and it is a more advanced version of UJT. So here how it looks like. Now the internal block diagram of PUT. You can see from here that it is a 4-layered construction. The topmost P layer is called the anode A. The N layer next to anode is called the gate. The P layer next to gate is left alone and the bottommost N layer is called cathodes. The symbol is also shown here. Now, characteristics of PUT. Here you can see this resistance R1 for base 1 and resistance R2 for base 2. Okay, so intrinsic standoff ratio eta, here you can see it is the ratio of R1 upon R1 plus R2. Now in this, the characteristics is a plot between the anode voltage and the anode current of PUT. The anode of the PUT is connected to a positive voltage and the cathode is connected to ground. The gate is connected to the junction of two external resistors R1 and R2, which will form a voltage divider network. It is the value of these two resistors R1 and R2 which will determine the intrinsic standoff ratio and peak voltage Vp of PUT, and these values are fixed by the manufacturer. When the anode to cathode voltage is increased, the anode current will also get increased and the junction will behave like a typical PN junction. But the anode voltage cannot be increased beyond a particular point, because at this point the sufficient number of charges are injected and the junction starts to saturate. Beyond this point, the anode current increases and the anode voltage decreases. This is equal to the negative resistance region characteristics of the PUT, which is similar in case of UJT. When the anode voltage VA is reduced to a particular level of voltage, this voltage is valley voltage and the point is known as the valley point because voltage decreases steeply in the form of the valley, nature of the valley. So the device becomes fully saturated and there is no more decrease in anode voltage in these characteristics. After that, the device will behave like a fully saturated PN junction. The peak voltage. It is the peak voltage. It is the anode to cathode voltage after which the programmable unijunction transistor will jump into the negative resistance region. The peak voltage generally drops up to the value of 0.7 volt plus the gate to cathode voltage Vg. The applications of PUT. It is used in the triggering of SCR and triac. The next application is PUT used as relaxation oscillator. The relaxation oscillator is of course the most common application of PUT. PUT can be used for generating a wide range of waveforms which is in the form of sawtooth. It is called as a relaxation oscillator because the timing interval is very large between, there is a relaxation in timing, that is why the name relaxation oscillator. It is also used in the timer circuit. Now the comparison of UJT and PUT. While considering the first parameter, the number of junctions, there is only one junction. Here in PUT there are three junctions. The value of next intrinsic standoff ratio. The value of intrinsic standoff ratio is constant in UJT, whereas The value of programmable unijunction transistor, it can be adjusted, but it can be adjusted by the manufacturer only, because the values of resistance which are given R1 and R2, those values are fixed by the manufacturer or the one by the company. Then the negative resistance region, it is present in UJT, it is also present in PUT. Application, UJT is used as a triggering device in timers as a relaxation oscillator, whereas PUT is also used as a triggering device in timers and as a relaxation oscillator. Now summary. We have studied all about what is meant by PUT. How is the operation of PUT? The VI characteristics of PUT, applications of PUT. Now, the assignment or the question, you can take it to solve. You draw the symbol of PUT. Sorry, here it is written by mistake UJT, but you will be able to draw the symbol of PUT. So you draw the symbol of PUT and you draw the layer diagram of PUT. Okay, so I hope you all have studied all about the PUT and you have understood all about PUT. So take care, stay safe, stay healthy. Thank you.